Last time we learned one way to calculate standard as a measure of spread. So today we're going to look at a different way to calculate standard deviation. I've got the same sample for the first period with the slices of pizza, 2, 3, 4, 4, 6, and 8. You may recall the mean is 4.5 and the standard deviation is 2.17. Now I have another way I can calculate these without actually using the mean. If you recall from last time, let's see if I can get my thing. Calculated it. We were subtracting everything, squaring, and then, if you might recall that, how we subtracted everything, squared, and then added them up to get the sum of squares, then divided, which we do for samples, took the square root, and got 2.17. So that's the difference. All right. Now we're going to take a look at x. And we're going to just look at x squared. So I'm not doing the mean, I'm just squaring the x. Okay. Now I'm going to add them all up. So if I add these numbers up, doing these, I should get 27. This is called sigma of x, where sigma means sum. All right? I'm going to add all these up, and I'm going to get 145. This is the sum, or sigma, sum of x squared. We really say sum, we don't really say sigma. All right? Why did I do this? Well, the book has, and I'm not going to derive it for you, an alternate formula for variance. By the way, it's usually easier to calculate the variance first and then find the standard deviation. Variance is standard deviation squared, which is what there. And it's equal to the sum of x squared minus the sum of x, square it, divide by the number of points, all divided by n minus 1. All right? So you might want to box this. This is a formula that you will refer to in the assignment for chapter 3.2. So let's go ahead and look at it for this example. Example, s squared. Well, these two, some people want to think they're the same thing. They're not the same thing. This is the sum of x squared, which is 145. This is the sum of x, 27, which I'm going to then square. So I have 145 minus 27 squared divided by 6, and I'm going to divide the whole thing by 6 minus 1. All right. So that means that s squared is 145. 27 squared is 729. Divide that by 6. Divide by 5. So s squared is 145 minus 121.5 all over 5, which is 23.5 over 5. So if you look at it, remember when we did SS, our sum of squared deviations, that's the same as that. They're the same. All right? So when I divide out, s squared is still 4.7, which means my standard deviation is the square root of that, and that's approximately 2.17.